Hey everybody, welcome back to Eastview Academy. I'm Maya.
I'm Amelia, and today's lesson is derivative shortcuts for logarithmic, exponential, and inverse trigonometric functions. First, let's start with derivatives of exponential and logarithmic functions. Here we have e to the u. The derivative of e to the u is e to the u du. So whatever you have here also stays there, and you make sure you take the derivative of the u for that answer. And then next we have a to the u. A is going to be a constant, so like 5, 8, anything like that. So the derivative of that is a to the u du times the ln of a. For ln's, the ln of u's derivative is du over u. For logarithmic functions, it's du over u times the ln of a, and a is this base number here. Let's take a look at some examples. We'll start with e to the u problems. Our first example is e to the 4x squared. Remember that the derivative of e's, or e to the u problems, is e to the u du. This up here in the exponent is our u, 4x squared. So we keep this here for e to the u, so the answer would be e to the 4x squared. But then we also need to times it by the du. So the derivative of our u is going to be 8x. So our final answer would be e to the 4x squared times 8x. Now we're going to do a to the u derivatives for an example. This first example here is 5 to the x cubed. Remember that the derivative to a to the u's is a to the u du times the ln of a, and a is going to be our constant. So for the answer, we have 5 to the x cubed, because that's our au, which is actually the original problem here, 5 to the x cubed times our du, which is going to be this x cubed's derivative, so 3x squared, times the ln of a, so it's going to be times ln of our constant, which here is 5. So the final answer is 5 to the x cubed times 3x squared times the ln of 5. Let's move on to ln examples. This example here is the ln of 4x plus 3. Remember that the derivative of ln's is du over u. So in ln problems, whatever is in the parentheses is going to be your u. So 4x plus 3 is the u. The derivative of 4x plus 3 is 4. And that's going to be, so that's our du. And then the denominator is going to be a u, so 4x plus 3. So the final answer is 4 over 4x plus 3, du over u. Let's move on to logarithmics. Our example here is log base 4 x squared plus 3. This here is going to be our u, and if you look here at the cheat sheet here, it's log, and then the base is a, so it's going to be some constant, and then u. So here we have 4 as our base, and then x squared plus 3 is our u. The derivative of logarithmics is du over u times the ln of a. Remember, a is our base. So for the top, we have our du. So the derivative of x squared plus 3 is 2x. All over, for our denominator, we have u ln of a. So we have x squared plus 3 times the ln of 4, for a final answer of 2x over x squared plus 3 times the ln of 4. Go ahead.
Hi everyone, now let's do the derivatives of inverse trigonometric functions. Inverse trigs are the ones where you see it looks like raised power to the negative first power, but that's not actually what it is. It just means inverse. And what you need to know is that Mr. Houck sometimes might write arc sine or arc cosine, any of these, just with arc in front of it. You should know that it means the same thing as the form where you might see the -1 at the top. So just know that arc sine is the same as that. And here I wrote down a sheet of all of the form of the derivatives for each of the inverse trig functions. And you see that I used u's instead of x's, and what you need to know about u is that it's used as like a dummy variable where you can replace u in these forms with anything you want. So let's say that you have the sine of 3x. The 3x is the u, so the u is whatever is inside of the parentheses for that inverse trig function. All right, and another thing that you should know is that most of these you see the du's on top, and du means the derivative of the u, so the derivative of whatever is inside these parentheses here. And lastly, you should just practice these, have them all memorized because it'll help you on tests and quizzes, and it may seem like they're hard to remember now, but it'll really help you in the future if you make flashcards or just review them with yourself every day. So now over here you can see that here's all the cheat sheets where you just plug and chug for the derivatives, and I'll go over them quick. So for inverse sine, you have the derivative of u on top, and that's over the square root of 1 minus u squared. For cosine, it's the exact same thing except it's just negative. For tangent, it's the derivative of u on the top divided by 1 plus u squared. For cosecant, it's negative derivative of u, and then on the bottom is the absolute value of u times the square root of u squared minus 1. Another thing that you should know if you don't already know is that an absolute value is always going to be positive on the bottom. Or not on the bottom, just inside the absolute value signs. For secant, it's the exact same thing as cosecant except it's just positive. And for cotangent, it's almost the same as regular tangent except it's just negative. I don't know if you've noticed yet or not, but if you notice, everything that has a c, everything that starts with a c, so cosine, inverse cosecant, or inverse cotangent, they're all negative. You see that right there? And obviously everything else is positive, but just remember that everything with the c is negative. All right, so now let's do some example problems. The first one is pretty easy and basic. It's just the inverse sine of x. And like I said, u is just a dummy variable. So here you see the derivative form for inverse sine using u's, but now all you have to do is plug the x in for u's. So you know that the derivative of x is just 1, so 1 on top, and on the bottom is the square root of 1 minus u squared, and that would in this case be 1 minus x squared, and you're done with that. The next one, inverse cosine of 2x, this gets a little bit trickier but not much. So the u in this is the 2x. Like I said before, the u is whatever is just in the parentheses here. And since it's cosine, it starts with a c, it's going to be negative. So the negative derivative of 2x is negative 2, and that goes on top. On the bottom, like inverse sine, 1 minus u squared. So 2x squared is simply 4x squared. So it'll be 1 minus 4x squared. And that one's done. Third, it's getting a little bit harder as we go on. For inverse tangent, like I said, here's the u, is whatever is in the parentheses. The derivative of x squared is 2x. That goes in the denominator, the numerator, excuse me. And like on this cheat sheet here, it's 1 plus u squared, and that would be x squared times x squared, which is x to the 4th. And that's done. Fourth, inverse cosecant of x plus 3. So here's the u. And inverse cosecant, remember it's negative since it starts with a c. It'll be the negative derivative of u. So the derivative of x plus 3 is just 1 over absolute value of u, so absolute value of x plus 3 times u squared. So you might have to do a little bit of foiling here. So x plus 3 times x plus 3. You do the first, outside, inside, last. And that's x squared plus 6x plus 9. But keep in mind, for cosecant, you also have to subtract 1. So under the radical, it'll end up being x squared plus 6x plus 8, because you had to take 1 away from 9. And you're done with that one. Next one, inverse secant. It's just like cosecant, except it's positive. So here's the u. The derivative of u is 2x plus 1, and that's over the absolute value of u multiplied by u squared. So again, we have to do some foiling. First, outside, inside, last. So that ends up being x to the 4th plus 2x to the 3rd plus x squared. And you put in that and you subtract 1. So that'll end up being x to the 4th plus 2x to the 3rd plus x squared minus 1. There you go. Last one is the trickiest, but it's easy if you just plug and chug into these equations right here. Inverse cotangent of sine of x. So here's the u. We know that the derivative of sine x is just cosine. So on the top is the cosine of x, and since cotangent starts with a c, it's negative cosine of x over 1 plus u squared. So it'll just be sine of x squared, which can be written like this. And there we go. All right, so now that we're done with our lesson, we hope that you know how to take a derivative of a logarithmic, exponential, or inverse trigonometric function. We want you to try these ones at home. So this is the ln of sine of 3x, and this is the 3 times the inverse sine of e to the x. It may look a little bit tricky, but if you really break it down into the 2 lessons that we taught you today, you should understand them. And once you're done, here's the answers to see if you got it right or not.
Thanks for watching.